Hello all, welcome back to Bitwise Smarter. If you have ever gotten a bright red Python error just because you added two things together, welcome to programming. You're officially one of us now. And no, you're not bad at Python. Python just hasn't explained itself yet. If you watched my previous video on Python for beginners, print input strings and variables, this video is the perfect continuation. In that video, we learned how to talk to Python. In this video, we are learning how Python thinks. We are turning those what just happened moments into oh, that actually makes sense. Today we'll cover Python's core data types, why type errors happen, how to check and convert data types, how Python handles math, rounding and cleaning up numbers, F strings, your new best friend. Then we'll level up with if, elif, else, modulo, nested logic, and logical operators like and or. And we'll finish with the final challenge that brings everything together with a full solution and explanation. Let's stop fighting with Python. Let's begin. I'll be using PyCharm as my IDE in this video, but feel free to use any editor you're comfortable with. If you want to download and install PyCharm, I've linked a step-by-step video in the description. Section 1. Python's core data types. Everything in Python has a type, and most beginner confusion comes from not realizing what type you're actually working with. Let's start with the four most common ones. First, integers or int, whole numbers, no decimals, age equal to 28, temperature equal to -5. Next, floats, numbers with decimals, price equal to 19.99, rating equal to 4.5. Then, strings or str, anything inside quotes, even numbers that look like numbers. Name equal to Bitwise Smarter, height equal to 162. 162 within the quotation mark makes them a string. And finally, booleans. Python's yes or no values. Is logged in equal to true? Is admin equal to false? Think of data types like containers. Each container has rules. Python enforces those rules strictly, and that's actually what keeps your programs reliable. Section 2. Why type errors happen. A type error usually means you're trying to combine things that don't belong together. For example, score equal to 100, bonus equal to 20, print score plus bonus. Python looks at this and says, one of these is a text, the other is math. What exactly do you want me to do? This is like trying to add a coffee mug to an Excel formula. Python isn't confused, it's being precise. Once we tell Python what we intend, the error disappears. Section 3. Type checking with type function. When something doesn't behave the way you expect, ask Python what it thinks. Use type function. Example, value equal to input enter something. Print type of value. Let's run this. I'm going to type hello. The output displays it is a string. Here's the big beginner surprise. Input function always returns a string. Always. Even if you type a number, even if you type 10 numbers. This one fact explains a huge number of beginner errors. Let's try it. Section 4. Type conversion. Type conversion is how we tell Python, I know this looks like text, but I want to treat it like a number. Example, user age equal to input, enter your age. User age equal to int of user age. Print user age plus 1. Let's run it. Now Python is happy because the types make sense. Quick recap. Int of string 42 converts a string to an integer. Float of string 3.14 converts a string to a float. String of integer 100 converts an integer to a string. Python doesn't guess. You must be explicit. Section 5. Math in Python. Let's run this. Python math works mostly like regular math. Addition, subtraction, multiplication, division. Notice something important. Division always gives a decimal. If you want Python to drop the decimal, use floor division. Powers use double asterisks. Python is very consistent once you know the rules. Section 6. Rounding numbers. Sometimes Python gives you numbers with way too many decimal places. That's where round function comes in. Price equal to 19.98765. When we print using round price comma 2, now the numbers look clean, professional and human friendly. Section 7. F-strings. F-strings are one of Python's best features. They let you combine text and variables cleanly and clearly. Example, item equal to coffee, which is a string, cost equal to 4.567, which is a float. Let's quickly break down this line. The print function just displays text. The F before the quotes tells Python this is an F string, which means we can insert variables directly inside the text. Anything inside curly braces gets evaluated first. Item within the curly braces is replaced with the value of the variable item. Round cost comma 2 within the curly braces means Python takes the value of cost, rounds it to 2 decimal places, and inserts the results here. The dollar sign is just normal text. So if item is coffee and cost is 4.567, this line prints my coffee costs $4.57. That's why F strings are clean, readable, and extremely powerful. You can include variables, math, and even function calls. Once you start using F strings, you won't go back. Now let's move to Python's decision making. Section 8. If-Else statements. If-Else is how Python makes decisions. Example, battery equal to int of input battery level. If battery less than 20, print low battery, plug in power. Else print battery OK. If the condition is true, Python runs the indented block. If it's false, Python runs the other block. Indentation is logic in Python, not decoration. Let's try it out. Section 9. Comparison operators. Comparison operators allow Python to compare two values and return either true or false. And this is important because if statements don't care about numbers, they care about truth. Here are the most common comparison operators: equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Now here's the most important beginner concept. A single equal sign, x equal to 5, means assignment. We are assigning the value 5 to the variable x. But double equals x equal to 5 means comparison. We are asking Python a question. Is x equal to 5? That question evaluates to either true or false. This is why Python doesn't allow a single equal sign inside an if. because if needs a question, not an assignment. Once you start reading comparison operators as yes or no questions, they become much easier to understand. Section 10. Modulo. Modulo gives the remainder after division. Print 10 modulo 3 will give 1. This is extremely useful for odd-even checks. Num equal to int, input enter a number. If num modulo 2 equal 0, print even, else print odd. If there's no remainder, the number is even. Let's try it. Section 11. Nested if statements. Nested if means a decision inside another decision. This is an example of a nested if statement, which means one decision lives inside another. First, we ask if the password is correct. If the answer is yes, only then do we ask for the OTP. Inside that block, we check the OTP. If it's correct, the login is successful. If not, we print that the OTP failed. If the password itself is wrong, Python skips everything inside and immediately prints wrong password. So the OTP check only runs when the password check passes first. Python reads this exactly the way a human would. Let's try it out. Section 12. If-Elif-Else. Use elif when there are multiple outcomes. This is an example of an if-elif-else statement, which Python uses when there are multiple possible outcomes. First, we ask how many hours the user plans to study and convert that input into an integer. Python checks the condition from top to bottom. If the hours are 1 or less, it prints light study. If that's not true, Python moves to the elif and checks whether the hours are 3 or less. If neither condition is true, the else block runs and prints deep work mode. Only one of these blocks will execute. Only one branch runs. Let's try it. Section 13. Multiple independent ifs. Sometimes multiple conditions should apply. This example uses multiple independent if statements, which means each condition is checked separately. We start with a base bill of $10. Then we ask if the user wants music and if they want video. If music is added, we increase the bill by $3. If video is added, we increase the bill by $5. Both conditions can be true, both can be false, or only one can apply. Finally, we print the total bill using an if string. Let's try it. Section 14. Logical operators. Logical operators combine conditions. This example uses the logical AND operator to combine two conditions into one decision. First, we ask for the user's age and convert it into an integer. Then we ask whether they have an ID. The AND operator means both conditions must be true. So the user must be at least 21 and they must have a valid ID for access to be granted. If either condition fails, Python prints access denied. And means both conditions must be true, or means at least one must be true, not flips the results. Let's try it out. Alright, this is your final challenge. Build a smart checkout system. Ask the user for item price, quantity, promo code, member status, delivery option. Calculate the subtotal. Apply these rules. Promo code save 10 gives 10% off. Members get $2 off. Delivery adds $5. If quantity is even, print a bonus message. Finally, print the total, round it to two decimals using an F string. Pause the video now. Give it a real attempt. Here is a probable solution. We convert inputs to the correct data types so Python can do the math. We calculate the subtotal. Each rule uses an independent if, so discounts can stack. Modulo checks if quantity is even. And finally, we use an F string with rounding to produce clean output. Let's try it. If you understand why this works, congratulations! You have officially crossed the beginner's barrier. And that's a wrap. If this video helped you, please give it a like. It really helps. Subscribe for more beginner-friendly Python content. Share this with someone who's currently fighting Python errors. Drop a comment if something clicked today, or if you want me to cover a specific topic. Keep practicing, keep experimenting.